In this video, we'll be talking about a chemical change. So a chemical change occurs when different molecules are in close proximity to each other, and the atoms or an atom in those molecules that are close together is attracted to the atom or atoms in another molecule in that close proximity. So when those atoms are attracted to each other that are in those molecules, they pull together the original molecules, and that pulls them apart, that attraction. And that attraction is also called chemical energy. So those molecules are destroyed because they that attraction between the atoms pulled them apart. But the same atoms still exist after, they're just in different groups. So those molecules were destroyed, but then they created new molecules. So that's basically the definition of a chemical change. You start with something, and because of that attraction or chemical energy, a new molecule is formed. So yeah, that's basically the difference between physical and chemical energy. In a physical, you have the same molecules before and after. It's just the movement of the molecules and the energy in there. But yes, in a chemical change, you don't have the same molecules before and after. There's a new molecule forming. So to investigate how this chemical change occurs, I did a little experiment. So I had two different stains. These were wine, and this is mustard. And I tested it with two different cleaners. So this column is OxyClean, and this is Shout. So what this was investigating, I was trying to see what would happen with one cleaner versus the other. And what I found was that the Shout, the molecules in the Shout, those atoms within the molecule in Shout were attracted to the atoms in the wine. And so those molecules pulled together and it broke that bond or attraction. So the stain was being destroyed and something new was forming. And with the mustard, you can see the stain is still there. So the atoms within the molecules in the mustard weren't attracted to either of the atoms in the molecules of either stain cleaner. So since they weren't attracted to each other, nothing new was formed. The stain still exists. They were attracted to each other with the wine in both cases, and so something new was formed. That molecule, the stain, was destroyed. Another way to show that occurring is with this model. So these are the molecules, and this is how much it weighs. It still weighs the same after the change, but these molecules do not exist over here. They're in new groups. So different molecules were formed. All the same atoms, the RT and the G and the B from here, all of those still exist, so it weighs the same. There's all the same atoms, but they formed new molecules. Another way to show this is with the paper clips. So this would be the model that I just showed you. So that right there, this would be that, and you'll see that it says it weighs 1.7 grams. And then we're gonna break this apart into two new ones. So there's that one and there's this one. These are two new molecules from this one big molecule. It weighs just about the same, 0.1 off. So basically that's showing that all of those atoms still exist. It's the same, weighs the same, because all of those atoms are still there, even though they're in different groups than they were before. So in terms of energy, the same amount of chemical energy still exists before and after. So this is just a little representation of that. 10 chemical energy, 10 chemical energy after. So in terms of cause and effect, so the cause for these molecules to change was the attraction between the atoms and the different molecules that were in close proximity to each other. Those atoms were attracted so much so that they pulled the molecules apart and formed new molecules. And that's the effect. The cause is the attraction. The effect is the new molecule being formed after. On a human scale, what you would see would be, a penny being dipped in a solution, or like a penny that had residue on it, dipped in a solution, and the solution is gone, or the residue is gone, because the molecules in that residue were attracted to the atoms in the solution. So they pulled together, destroyed that old molecule, destroyed the residue, and formed something new, formed new molecules. On a molecular scale, that's basically what I showed you with this model. You see the molecules beforehand, and then they're in different molecules, but the same atoms still exist. And that's also what the paper clips represented as well. So basically, to reiterate, a chemical change is when the atoms from two different molecules are attracted to each other, breaking the molecule apart and forming new molecules. That's different than a physical change, because in a physical change, the energy is changing and the molecules are in different positions, moving, pushing harder and so on, but the same molecules exist before and after that change. So that's it.